turbo design 1, we can start a new optimization using this option here. And then we select the target case, which is the baseline rotor, and the workflow, which is rapid single point or MOGA, and specify some optimization settings. And with that, let's open the various Optima related windows and rearrange them a bit first. So for the input parameters, we can see that the stream-wise loading at the hub and shroud have been pre-selected. And we can add the mid-span loading parameters. And also the thickness scaling at the hub and shroud, because it has an influence on the blade stress. And of course, it's possible to set the range of variation for the different input parameters as required. Proceeding to the constraints, we already have the throat, and we can add the maximum surface Mach number, diffusion ratio, and the hub cross-section area like this. And set their appropriate ranges. And finally, coming to the objectives, we want to minimize the profile and end wall losses to raise the rotor efficiency. But we also want to minimize the maximum lean and centrifugal stress to keep the blade integrity in check. And with that, we are ready to start the optimization. Which we can do by clicking the run button here. Now once the optimization is complete, which is very fast, and for 1600 designs it takes less than 8 hours on an office workstation, we can see these designs have appeared on a scatter plot between two of the objectives. Next, we can choose to see feasible designs which respect all of our specified constraints. and from which we can pick and analyze any design of interest. And in this case, we select the design from close to the Pareto front that gives us a good trade-off between the profile and end wall losses. Now we can also check where our selected design sits in terms of the other two objectives like this. And although it doesn't exactly sit at the Pareto front, but the maximum lean is still quite reduced compared to the baseline rotor with a similar level of centrifugal stress parameter. And so the selected design can be expected to have good blade integrity. And then with this option, we can generate the optimized design and then compare its performance parameters with the baseline rotor in this project manager window. And clearly the aerodynamic parameters are much improved. Without adversely impacting the mechanical parameters. With the constraint parameters staying within the acceptable range. And if we then compare the blade geometries in the 3D plot like this, then we can easily see that the optimized blade is actually looking quite different from the baseline rotor, and the change in thickness is also quite obvious. And finally, this optimized design can be exported for CFD and FEA analysis. And in this way, a rapid multidisciplinary optimization of an axial turbine rotor can be performed in Turbo Design 1.